Well, for question 1b, we're going all the way up 1 plus z squared, all the way up to n this time. And so, same thing, geometric series, a is 1, r is z, and this time n is actually n plus 1. And our geometric progression formula, so it's a, which is 1 minus r to the n, all over 1 minus r. And this time the n is n plus 1. Now, I want to split that n plus 1, as I accidentally nearly did there, into z to the power of n times by z. Because, look, that's n plus 1, isn't it? And so there. And now I'm going to put in what z is. And we were told that z equals, same as last time, it was e to the I pi over n. E to the I pi over n. So I've got 1 minus e to the I pi over n to the n times by another e to the I pi over n, all divided by 1 minus e to the I pi over n. And the reason why I did that is that on this point here you can see these n's cancel, so I just have an e to the I pi there, e to the I pi being minus 1. And so we can have a little breather when we get to the point where this is 1 plus, minus here, e to the I pi over n over 1 minus e to the I pi over n. Now I have to confess I've practiced this question. I don't practice many questions before I do it, but I went wrong a few times, and it's because of this line here. There's lots of different routes through it. But I'm finding that the best way of working out from this point here is almost splitting up the I pi's, splitting up how many you've got in each place. So what I'm suggesting doing here is that we've got over n of them. I'm going to put half of them here, e to the I pi over 2n. I'm going to make that one minus, and put half of them here, e to the I pi over 2n. How have I done that? Well, what I've done is I've multiplied each of them by e to the I pi over minus 2n. Let's just pause and think that through. Right, no, there's no minus there. Let's get rid of that minus. So look, if I multiply that out, those two things times together gives e to the 0, which was 1, and those two things together, we get 2, sort of I pi over 2n, another I pi over 2n, so that's 2 of them. Yeah, that works, that one there. I'm going to split the bottom as well. Same thing here. I've got e to the I pi over 2n, e to the minus I pi over 2n. And again, I took out a factor of e to the pi over 2n. And so I've been doing a few more of these beforehand, and the trick seems to be, say, to split this up. Whatever you've got there, do half of them, take half of them out, so you get a minus and a plus. And the thing about this minus and this plus version now, then, these are the formulas for the cos and the sine, aren't they? Well, not quite, but the same sort of thing. Right, these two bits can now cancel. This bit on the bottom here is a cos of pi over 2n, but because that's all over 2, so I've got 2 of them. And this one here with the minus in the middle there, that is the formula for the sine of pi over 2n. But that would need a, what would that need? That would need a minus 2i in the bottom. So I put a minus 2i there. The 2's cancel. I've got an I on the bottom, which I don't want, so I times by that to have an I on the top. That I on the bottom will now be an I squared, which is a minus 1, times by that makes 1, and cos of a sine is the cot that we were trying to get. And that's the answer they were aiming for. And being that early in the exercise, I think that's quite tough. But if you can get through that, some of the later ones are simple.